In today's lecture, we are going to discuss about the new chapter. That chapter is structural geology. An outline that there are basically two things. First one, it is an introduction. We will see that what is an outcrop and what is stratification, and then tip and strike and its relationship. So this will be the topic I'm going to discuss today. Okay, so if we're talking about structural geology is the branch of geology which deals with the morphology, classification, causes, and development of any other aspect related to the structural features or rock is known as structural geology. So if you are studying a rock, till today we studied about the rocks and we discussed about its formation, stages, structure, and texture. There also we used one term, that is structure. But in geology, if you see the structures, there are basically two type of structures which the rock forms. So the first one, what you have already studied, the structures which are formed during the process of formation of the rock. So that we call it as a primary structure. So here what you see is a stratification, okay, or the strata which are horizontally formed, and this is as a result of the process of formation of this rock. What does it indicate? The first layer of the rock formed, then there is another layer of the rock formed, the sediment formed, and then sediment converted to a rock. Here it produces a very well stratified rock. Correct. So this is a primary structure. Now what we are interested right now at this chapter is basically the secondary structures. And what I mean by the secondary structures, after the process of formation of these sediments or these layers, this rock undergoes some kind of deformations, and as a result these horizontal layers what you see here right now has got changed. It has got changed to something like this. Okay, here if you see, so see this is a layer. What you see is a layer is now completely folded in nature. When it was depositing, this must have deposited as a horizontal layer, but after that process of horizontal layer formation of this rock, which got under some kind of pressure, if you remember the formation of Himalaya and the tectonic forces what we have discussed in the previous lectures. So there are a number of forces which are acting on the rocks, and if you want to just imagine the power of these forces, you just imagine that we are having a Himalaya which once upon a time, millions of years before, the Himalaya was a sea. The place where Himalaya is right now was having a sea, and the dead sediments which are deposited under the sea or the bed of the sea is now we are getting at the top of the Himalayan mountains. So the amount of force which have applied to these rocks and it got folded and which got converted to a mountain, so that we can imagine that how much amount of energy, or it is a very long process, duration of process, not a very small duration, but it is the process. But right now when we see these things today, and there is still, if you see the process which still continues, as the GPS studies are showing that the Himalaya is building up. It is again building around 5 centimeter per 5 centimeter 5 millimeter, I don't remember exactly right now, but it's a very small amount of growth, the height of the Himalaya which is increasing. At the same time, our Indian subcontinent as a whole, it is completely moving towards the north and hitting the Eurasian plate. Okay, as a result there are number of energy but the process is very small. It is like the amount of 1 millimeter or 2 millimeter or 10 millimeter per year or something like that. Okay, so this moment is very small when we compare the size of the Indian subcontinent, but even if it is in millimeter scale, the amount of energy which involved is very huge, and as a result what will happen, the rocks which are present in this crust that get deformed. The deformation process, we call it as a the study of these deformation processes and understanding these deformation processes and the features which developed by the process of this deformation, we call it as a structural geology. So the structural geology, in this chapter we are basically going to study about the secondary structures what we have not discussed it, but this the primary structures, the structures which are forming during the process of formation of the rock, the cross beddings, laminations, ripple marks, rain marks, flow structure, pillow lava, ropey lava. So all these different gneiss-osity, schistosity, all these things we have already studied in the different category of rocks. Right. So here in this chapter we will be studying primarily about the secondary structures. Okay. So when you are talking about the secondary structures, but how do we study? Because if people we are here right now in the state of Gujarat, and basically the people who are located in the mainland Gujarat, like from Ahmedabad to the Valsad. So the stretch what we get is mostly the alluvium covered. Alluvium covered means it is very loose soil what we are seeing on the surface. We rarely see any rock types on the surface. But the people who are in Kutch or in the Bhuj or Kutch region or in the Saurashtra region, they will be very familiar with kind of the rocks which are exposing on the surface of the rocks. So when you study the earth's surface, for example, if I look into a small part where some areas we will have this kind of large rocks which are exposing on the surface. Okay, so if I stand here in front of me, I'll see a rock. Okay, so this kind of rocks or the natural exposure of rocks on the surface is known as outcrops. Okay, so this is what one of the major source of information for any geologist before we go into any kind of detailed geotechnical studies, or before we go into the details of bore wells or study into any geophysical methods. These are the basic informations provided to a geologist when we study a area. Okay, so when we study an area, for example, the geologist will be going into the area and he will study the rock, and while studying the rock, what the geologist is interested to study is the attitude of the rock. What is this attitude? Attitude of a rock is its some parameters. We'll see that what kind of parameters it are. So while studying these rocks, the geologist will be studying the attitude of the rocks. While studying the attitude of the rock, the geologist or the person who is studying this rock will be more interested on this kind of surfaces. And what is this surface called? This surface is called the bedding planes. Okay, so the bedding planes are if I remove this or layer from here, when the surface is horizontal surface what you are getting here, we call it as a bedding plane. Bedding plane is a small break in between the process of formation of this layered sedimentary rocks, or it may be any kind of change in the soils, because here if you see, we can see that the rock what you are seeing on this part is completely different or almost different from the rock which is on the lower part and the upper part. So this layer indicates that there is some changes in the characteristics of the sediments which was providing to this region, and that may be of number of reasons. It may be a climate, it may be a source area, it may be a type of erosion, anything. Okay, so that surface which formed, we call it as a bedding plane, and that bedding plane is here. Now we are seeing in a inclined way. Now the bedding plane is not horizontal, because here in this rock type, the rock type has undergone a deformation. What is the deformation? It was deposited as a horizontal type of rock, now is having a dip angle theta. Okay, dip angle theta towards some direction. So this rock types we call it as a inclined rock strata, and that is basically identified based on its bedding planes. Okay, so what we are interested as a person who is studying the rock type right now, this kind of bedding surfaces, and this surface is little bit of eroded. That is okay, but when we study a geologist go and study, then they may clear some part of this soil and study the rock type or little in the below the surface. So clear some soil and study the rock type, so that we get a uneroded fresh surface or fresh bedding planes that we need to identify. Okay, now just imagine this is our earth, and you know that what are these white lines indicating? What is this white lines indicating? These white lines we call it as a meridians. Remember that we studied in the previous semester that these are meridians. That means these are an imaginary lines which is connecting our north and south pole of the earth. Okay, so there are two types, if you remember, that the magnetic meridians and the true meridians. So true meridians are basically based on the geography of the or the shape and size of the earth, and the other one, which is the magnetic meridian, is basically the direction of orientation of a magnetic needle, which will show when it is freely suspended. If you take a free magnetic needle and allow it to freely suspend, then it will show or it will align parallel to the direction of the polarity of our earth. So that polarity we call it as a magnetic meridian. So this is an imaginary line which connecting the magnetic north and the magnetic south, that we take it as our reference line. Okay, now for example, if I see some small part of this, and suppose this is an imaginary cross-sectional view on this area, and here in the surface, what is there? There is a rock which is vertical, completely vertically cutting the strata, small rock type. So that is the area what I am showing here. So there is a rock, something like, which is completely cutting in a vertical way to the surface of the earth. So if I stand over the surface and see these rocks, it will show a direction something like this. It will show a rock type on the surface something like this. Now if I need to find the direction of this line, if you need to find the direction of this line, you know what to do. Identify one point here, point A. Okay, identify another point here, point B. Take your tripod and compass or theodolite or a total station or a GPS, anything, and intersect to this. Then find out the direction of this line. When you find out the direction of the line, you get something like, for example, it is aligned north to south. Here the things was very easy because the surface of the rock where it is like a vertical wall what we have created, and if I'm asking you to find out the direction of a wall, we can easily do that because we know that the north and south is imaginary, and we first align that to, if you remember the practicals what you have done in the previous semester, to identify the direction of line A, B, BC, CD and all. So same thing what we can do here. This is not a problem because this is a very vertical rock strata what we are getting on this surface. Now in the other case, if the rock strata is not vertical, okay, that is slightly inclined, then what will happen when you see the surface is a little inclined, so we are not able to correctly identify the direction of that line, which line I need to identify or which line I need to measure. So in that case, what we can do is that I can imagine a horizontal plane. Imagine a horizontal plane, and when the imaginary horizontal plane imaginarily cut this inclined strata, the joining of these two surfaces, the horizontal plane and the inclined plane, that becomes a line, and the direction of that line we can find out. So that will become the direction of this rock strata. Here I did not do this imaginary plane because this was a vertical strata, and the surface what I considered here itself is a horizontal strata. But in this case the strata is slightly inclined. Because it is slightly inclined, we are not able to identify the correct direction of that rock. So what I need is an imaginary horizontal plane. This is what the imaginary horizontal plane what I considered here, and when I keep this imaginary horizontal plane over the inclined surface of this rock strata, that intersection makes a point as a line, because when you intersect two inclined strata, it will go together and intersect and make a line. So the direction of the line, because we can find out the direction of only lines, we cannot find the direction of a point, we cannot find the direction of this this three-dimensional feature. We need to find out the direction of a line. And what is the direction of that line? And what is that line? That line is the line produced by what? The inclined rock strata and an imaginary horizontal rock strata. It's simple. Because when the rock on the crust which exposed to the surface, it will expose an inclined way somewhere, and when you are identifying the direction of that, I just imagine a horizontal strata, and just imagine that I am keeping a horizontal strata, and then horizontal strata may be a cardboard or a notebook what you are having, you can keep it horizontal, using a level, and you can just mark a line on the surface. So that line will produce the direction, and that direction we can measure using a compass. So that direction I can measure in this case, correct? So these measurements of directions what I am doing right now here is called a term in geological point of view. It is the strike. STRIKE, strike. What is strike? Strike is the geographic direction. Geographic direction means either it is north 10 degree east, north 20 degree west, whatever the compass survey that we have done. Okay, so this compass survey, when I identify the direction of line AB, here we are identifying the direction of a rock or a line which is formed by what? Which is formed by two things. One is an inclined plane. Inclined plane is the inclined rock bed, and a imaginary horizontal plane. So imaginary horizontal plane is this imaginary horizontal plane, and this is the inclined rock. But here I could not do that because this is an imaginary horizontal plane and this is a vertical strata. Same thing what I did here also, both the cases I have done the same thing, but in the first case I did not consider that because already the rock is vertical, so I can keep the compass or at anywhere and I can measure the distances. But in the case of an inclined strata, the line which is joining between two, what are the two surfaces? One is an inclined surface and other one it is a horizontal imaginary plane. So that two things will intersect together and they will make a line, and the direction of that line we call it as a strike. Okay, here in this case what it is shown, a surface, this is a surface, if you see, correct, this is an inclined surface, and this inclined surface is making a imaginary line by how it is intersecting with a horizontal plane. So the horizontal plane which is shown it as a water. So if you have putting water in the lake, the water will always remain the horizontal. So the line where the water intersects, so that will become the surface. And if the surface is not straight, if it is not a plane, bedding plane, then we will not get a straight line, we will get a curved line on this part. That is what I was telling in the initial stage. Whenever we are finding out the attitude of rock strata, we should go for a bedding plane that is assumed to be a plane surface. Okay, so that is the straight line will only become if it is the surface is plane, and if the surface is not plane, what will happen? The line will become something like this. So this line we will not still not be able to measure the direction. So we need to find out the bedding plane, and the bedding plane if it is there, then only if we will find the direction. And if the rocks are horizontal, then we cannot find the strike of that strata or the bedding. In that case, what we will go for is any kind of features. Like example, if this is the rock strata which is horizontal, then we can go for the direction of this linear features what we see on this rock surface. Okay, so horizontal strata, because rock is horizontal, so what direction I will measure? I cannot measure the direction because things are horizontal. Okay, so the strike of a line which is inclined, then we will do is we will find out an imaginary line. What is that line? That line is the intersection of the inclined strata and an imaginary horizontal plane. Clear? So this is what we call it as a strike. And if you want to see the strike with a simple form, so the line where it is joining the two surfaces of a the house roof, this is the direction. Okay, so this direction will be indicating the strike of the strata. Now when I say that the rock is inclined, so the inclined stroke will have a strike. At the same time, that will have an amount of inclination also, right? So here what it is showing is the amount of inclination, and this amount of inclination we can have at any direction also. Okay, so this inclination right now it is dipping the inclined towards this side. So sometime in other rock if it is marked as south, sometime in other rocks there may be inclined towards east, sometime in other rock it may be inclined towards north, some other rocks may be inclined towards west. So this inclination is a parameter. This can be a 40 degree, 20 degree, 90 degree, anywhere between 0 and 90 the rock can incline. So that inclination is called a other parameter, that is dip. Dip is the angle between the inclined plane and a horizontal imaginary plane measured along a vertical plane. Don't confuse with the measured along vertical plane. Here in this image, if you see the horizontal vertical plane, just imagine this plane. This plane is something like cut in a vertical way, correct? So where we are measuring the angle on the vertical plane. So this plane we consider it as a vertical plane, because if this angle, this is not vertical, then the angle may slightly vary. So this is what we call it as a dip. So dip will have two components. What are the two components? It will have an amount, okay, that is 40 degree, 30 degree, or that is an angle. At the same time, it will have a direction also. Whereas strike will have only one thing, that is a geographic direction, correct? Northeast, southwest. Here in this case, southwest, northeast is the direction, then this is the direction of the dip. Strike will have only one thing, that is the direction, whereas dip will have direction and amount. How much it is dipping? It is nothing. When you take a, if you hold the book, you can hold the book horizontally, or we can slightly incline the book towards your right hand side, or we can slightly incline the book towards your left hand side. You can slightly incline the book towards your front side or in back side. So that is possible. So any direction out of any direction that the rock can incline. Okay, so that can dip. So the direction of dip may be anywhere between 0 to 360, and the amount of dip would be anywhere between 0 to 90. So dip will have two components. What are those components? It will have a direction and a amount. So this is dip and strike. So we call these parameters are the attitude to measure for a rock strata. Okay, so when you go deeper into that, the dip have different parameters. One is called true dip and other one is called apparent dip. For example, this is what you see on the surface. What you see on the screen is a rock strata which is dipping towards this direction. Now if I find out, then I can say, okay, this is dipping towards this side also, this is dipping towards this side also, this side also. Okay, so there are n number of directions I can find out from here. This is a number of values we can find out it is dipping. But when we measure the value, what I can find is that the dip amount in this direction is less. When I measure this, is slightly increasing. When I measure this, is slightly increasing. Then it is increasing. Then it is increasing to reach this direction. Then slowly the dip amount decreases. So this is one single direction where that will have a maximum amount of dip. So maximum value will be, how many number of maximum values will have? Maximum values will always have only one value, because that is the maximum. But how many number of other values will have? We can find n number of directions where, which is between 0 and this maximum value. Maximum is, I said, it can go up to 90 degree, and if it is going more than 90 degree, then you will measure it on the opposite side. It is dipping towards other direction will change. Okay, so maximum dip value is called the true dip, and this maximum value would always be perpendicular to the strike direction. I'm talking about the direction. If it is north and if it is south, the direction of this line is north south, then the direction of dip should be either west or it can be east. In this case, it is towards west. For example, if north south strike can have two true dips, either should be towards west or towards east. Now you tell me that if the strike of the strata is east west, so what are the two possible true dips? It can have true dips at towards north or towards south, correct? These are the two directions. Now we need to find out actually in which direction it dips. It cannot dip in both the directions. Either of these would be the direction where it dips. So the true dip is the one single value which is the perpendicular to the direction of strike, and the amount will vary. Here I am talking only about the direction, not talking anything about the amount. So I can have a dip which is towards north and 10 degree. I can have a dip which is towards north again, but it is 30 degree. I can have a dip which is towards north again, but it is 40 degree. So number of amount of dip can vary, but the direction of true dip will remain same for all the for that particular kind of strike. Okay. So any other dip which is other than that of true dip, we call it as a apparent dip. Apparent dip is the dip angle measured any other direction than true dip is called a apparent dip. Okay, so what is the practical use of these things? For example, this image you have seen earlier also. Now see this image where we are on the surface, and this part all are grassland, there is nothing exposed. But the people or the person standing here is a geologist, so he can see some rocks which are exposed here in this part. Okay, so what he'll do is that he'll go to that area, he'll identify the bedding plane, and what we identify, he will identify the strike and dip. When he identify the strike, we got this is the direction of the strike. Any direction, let us take it is north south. And when you identify the direction of dip, then we found it is towards west. Perfect. So the rock which is exposed here, and he identified that rock type is a sandstone, same rock type. Now he comes to the second location, that is somewhere here, and there also a small portion, and in between there is no rock exposed. So there also there is a small rock exposed. What he did, he identified the strike direction and the dip direction. Here also he got north south as a strike and the dip direction as east, which a distance apart the rocks are showing something like dipping into different directions. What is the interpretation? The interpretation is this. What is the interpretation? In the interpretation it says in the below the surface the rocks are something like this. They are inclined towards one direction and inclined towards other direction. So this kind of dipping or the structure, we call it as a fault, and to the interpretation what we get is the area is having a folded strata below the surface. But the person who is playing here, swimming here, they will never understand the small portion of rock exposed here is giving me an idea. The subsurface rock strata is not horizontal, rather it is folded in nature. And if I am planning for a building in this area, I should know that I am going to construct the building in a particular part of the fold. We will discuss it in the next lecture. What are the parts of this fold, and that is may not be suitable for a construction and using it as a foundation. This is the practical use of the understanding of strike and